Incredible images of the Pluto system have been streaming in from New Horizons over the past months, and what a sight! As far from an ancient dead world similar to Neptune's moon Triton as many people expected to see, what we've instead been observing is a dynamic and evolving world which has been sending shockwaves through the planetary science community, and now the first scientific results have just been published. So let's take a look at the surprises that Pluto has revealed. It was hard not to get carried away with Pluto fever, particularly if, like myself, you're part of the generation that never got to experience the thrill of the Voyager flybys and their incredible discoveries. But now, 3 months after New Horizons' historic flyby, the dust has largely settled, and so I want to dive straight in to examine some of the big scientific surprises that this mission has revealed, and moreover, what their wider implications could be. Here you'll see one of the highest resolution global portraits of Pluto returned to date, colour enhanced to demonstrate the incredible diversity of surface features. The sheer contrast between the highly reflective heart-shaped region, tentatively named Tombau Regio, and the dark red landscape of Cthulhu Regio to the west is immediately apparent, as is the bluer regions just south of the North Pole. So what causes these differences in colour? If we zoom into the west of Tombau Regio, we see a clear boundary between a mostly flat surface called Sputnik Planum and Cthulhu Regio. Switching to near-infrared wavelengths, Sputnik Planum seems to be absorbing more light at 1.66 and 1.79 micrometers, as indicated by the red shading. These absorptions are a characteristic signature of methane ice, and a similar absorption observed at 1.58 micrometers indicates the presence of carbon monoxide ice, these together explaining the white colour of Sputnik Planum. Cthulhu Regio's red colour, on the other hand, is speculated to be due to a complex tar-like mixture of organic compounds called Tholins, which form when UV light or charged particles interact with nitrogen and methane in Pluto's atmosphere or on its surface. The presence of these ices, which were actually known by ground-based observations before New Horizons arrived, also goes a long way to explaining the blue regions to the north, which are seen to vary as a function of the angle between the surface and the sun, so that suggests they could be due to sublimation of the ices, where the ices change directly from a solid into a gas as they're heated. But one thing that can't be explained is the observations of these 2 to 3 kilometre tall mountains that we've seen in Sputnik Planum, because nitrogen, carbon monoxide and methane gas just are not able to support their own weight over geological timescales for such large structures. So it's instead been proposed that an underlying bedrock, if you will, of water ice hides underneath the surface ice, and wherever there's just a gap in the surface ice, or maybe due to tectonic activity, the bedrock can push outwards and form these mountains. We've seen in the north of Sputnik Planum evidence of them flowing like glaciers effectively around hills and into craters on the northern border of the region. There's also some weird polygon-shaped cells tens of kilometres across observed throughout Sputnik Planum of uncertain origin. It's been suggested that they could be caused either by surface contraction or perhaps by fracture due to uplift of subsurface material, but perhaps the leading hypothesis at the moment is that they're due to internal convection in the solid state within Sputnik Planum itself, which could also go a large way towards explaining the flows of these surface ices that have been seen to the north of the region. The problem with this, though, is that no one expected to see this level of activity on Pluto. Indeed, the fact that we've seen no confirmed craters in Sputnik Planum means that the surface must have been replenished within the last 100 million years. So then it's a natural question as to what can power this? Because usually in icy bodies in the solar system, this will be powered by friction due to the tidal interaction. But with Pluto and its largest moon Charon, they have near zero mutual eccentricity in their orbits about their centre of mass, which means that this is not a viable heating mechanism. So it's been suggested that Pluto by necessity may have a much more active internal heat source than had previously been imagined. Indeed, planetary scientist John Spencer has suggested that radioactive decay, an important source of heat inside of the Earth, could be playing a role inside of Pluto, which would be a very interesting conclusion to say the least for small bodies. One other potential explanation is that Pluto has somehow found a way to retain much more of the heat from the collision that formed itself and Charon billions of years ago than had previously been imagined. One way that you could accomplish this, for instance, is by having a subsurface ocean of liquid water that's been releasing heat gradually as it's been freezing over time. But it's not just Pluto's surface that has been firing off people's imagination, as its stunning blue atmosphere appears much more extended than previously imagined, stretching outwards to an altitude of 1,670 kilometres. It's primarily composed of nitrogen, methane and carbon monoxide, with the colour being due to a number of hazy layers of tholins in the bottom 150 kilometres, clearly visible in this image taken from 18,000 kilometres away from Pluto, as tholins are remarkably effective at scattering blue wavelengths. A special mention has to go to Pluto's moons though, some of the smaller ones having just had their first images downlinked. In particular, if we look at Nix and Hydra, they seem to be much more reflective than previously imagined, indicating that the quality of the water coating their surface seems to be much cleaner. The weird thing though is that radiation and impacts tend to darken surfaces over time, not make them brighter. And if we also take a look at Kerberos, it looks like it's made of two separate units fused together, perhaps similar to Comet 67P. The largest moon, Charon, seems to be remarkably varied for a body of only 600 kilometres in radius. We've seen mountains up to 3 kilometres high, faults, craters, markings, as well as fractures up to 60 kilometres wide and 5 kilometres deep, certainly giving Valles Marineris on Mars a run for its money. Indeed, this clear evidence of tectonic activity on Charon was perhaps more surprising for many geologists than Pluto itself. And if we look at the north polar region of Charon, it seems to be existing in a crater, perhaps from an impact billions of years ago, and it is very red in colour, appropriately naming this region Mordor Macula. Oh, I really hope these names get approved, by the way. But why is Mordor red? Well, it's been suggested that volatile compounds could have gradually collected in the crater of Mordor and then reacted with UV photons over time to form, yep, you guessed it, tholins. And again we're back to these weird tholin things, which seem to be complicated collections of over 10,000 different types and different species of organic hydrocarbons. There's an interesting point here actually, that tholins could actually tell us a lot about the origin of life here on the Earth. Because you see, when the first life was developing, way before the first, what's called the Great Oxygenation event 2.7 billion years ago, that life was very vulnerable to UV photons from the sun. So it's been suggested that a layer of tholins delivered to the Earth via comets may have protected the first life in its crucial phase of development. So I think it's somewhat profound to think that even 4.7 billion kilometres away from home, we're still learning about our origins. And I think this really gets to the heart of why we explore and push out further and further out into space. It seems that the Pluto system just keeps teaching us new things. In particular, the similar densities of Pluto and Charon seem to imply that the bodies that collided to form them billions of years ago were undifferentiated, meaning that heavier elements didn't have time to fall towards their centre before the collision event. And this could have potential implications actually for our entire theory of planetary formation as to how bodies form from dust in the Kuiper belt. And you know, this is what I love most about science. That moment when we discover something completely unexpected that forever changes our understanding of the world. And as successful as New Horizons has been, it's likely barely scratched the surface of the mysteries the Kuiper belt has in store for us. So as New Horizons ploughs onwards and outwards towards its next target, 2014 MU69, for a flyby in 2019, it will continue to beam back the 50 gigabits of data taken on July 14th. So who knows, Perhaps the biggest surprise is yet to come. Thanks for watching, and if you're interested in learning more about the findings from Pluto, I'll link to the New Horizons team's paper in the journal Science down below. This week's featured video is a look at another outstanding mystery in planetary science, namely the origin of the moons of Mars. But next time, I'll be starting a new weekly series on astrobiology and the search for life in the universe, starting with an objective look at the science of how you might detect transiting alien megastructures. Be sure to let me know what you'd like to be included in this new series down in the comments, and subscribe so that you don't miss it.